Alright, so you should have at the top of your notes labeled standard form, chapter 3, section 2. Essential question, how do you find the vertex of a quadratic written in standard form? Because the quiz we just had was in a different form. The quiz we just had was in vertex form. Vertex form is the y equals a times x minus h squared plus k. You will write that so many times this year, you will be able to write it in your sleep. The a's, h's, and k's. For the next 2 years, we're going to be talking about a, h's, and k's. So if I gave those numbers, an example would be like y equals 2 times x minus 4 squared plus 5. Just by looking at that, you can tell me the vertex. Because, watch my hand and say it with me. What do we say? Opposite, same. Opposite, same. So the numbers for the vertex would be opposite of this guy, which is positive 4, same, which would be good. So the vertex of that is 4, 5. Standard form is not as convenient, but when you get further into math, usually your quadratics are written in standard form versus vertex form. Vertex form is really nice because you can see everything. You can see the shift, the horizontal shift. You can see the vertical shift. You can see the change of slope. You can see the vertex just by looking at it. Standard form, not as convenient, but why would we use it? Because it's a simplified polynomial. There's some a and x squared plus bx plus c. You can see the trinomial there. The reason we would want to use this one is because it's easier to factor, which we will be learning like a week. Ooh, factoring. We talked about a greatest common factor already, but we're learning how to factor a quadratic. So standard form, the a, the b, and the c are going to turn into integers. They don't have to be integers actually, they can be fractions, but they're numbers. But you can't see the vertex just by looking at that standard form. Okay, the nice thing about standard form is you can find the axis of symmetry pretty quick. Do you remember what the axis of symmetry is? We've talked about this. Yeah, say that again. Not a point, but the line where it folds equally, right in half. So like this guy, 4, 5. If I was to graph that, 1, 2, 3, 4, 5. There's 4. The vertex has been shifted right 4, up 5. Remember the ratios? You can do an XY table to get points, or I can use my ratio, 1 over 1, 4 over 2, but I know we have a multiplier of 2. So if I times by 2, I'm going to get 2 over 1, which means I go up and 1, 5, right? Okay. I go up 2, right, and left 1. Rise over run. The next set of points, if I use my multiplier, I would go up 8 from the vertex, run 2, which is off my graph. So just for today's purposes, we'll just do that. The axis of symmetry, like she said, is the fold line. Notice, what does it go straight through? It goes through the vertex and the x-axis. So it's the x-coordinate of the vertex. And we abbreviate axis of symmetry sometimes AOS. It's the x-coordinate of the vertex, and it's a line that goes through the x-axis. So the axis of symmetry has to be an equation. If it's a line, it's an equation. So make sure we use an equal sign in our answer. Here's the formula for axis of symmetry. X equals negative b over 2a. negative b, bless you, over 2a. B's and a's come from your standard form. So if I was to give you a standard form, y equals, actually let me grab this one right here, x squared minus 6x plus 4. Identify what's in the B position. I don't know if you can do that one with fingers in the air. Maybe with you and your neighbor you can show me that one. You and your neighbor, what number is in the B position? There you go. There you go. Teamwork. There we go. How do you do this? Yeah, do you agree with those two A's since you don't have a partner? Sure. Good. Gabe, what'd you get? Negative 6. So for the axis of symmetry, quiet down please. The axis of symmetry, the numerator is opposite of that. So we have a negative 6, which becomes a positive 6. Over 2 times finger in the air. What is the A? Good, she got that up really fast. What is the A? What's the value of A? Thank you. Not 4, that's C actually. It is just 1. A is the number in front of the x squared, which is 1. So if we simplify this, 6 divided by 2 is 3. So the axis of symmetry is not 3, it is x equals 3. X equals 3. Which means on the graph, 1, 2, 3, our vertex is going to be somewhere along that dotted line, and that's the fold line for the quadratic. We can find the vertex by plugging in the x. To find the vertex, plug in the axis of symmetry. So, where do we plug into? Raise a hand. Anyone have ideas? Where do I say plug in? What am I talking about? Yeah, it's Brindy. Yeah, the original equation. Wherever there is an x, we know x. X is 3. Wherever there's an x, so we write y equals, I have an x squared. I put parentheses whenever I'm plugging in. So I'm just going to go through, and wherever there's an x, I'm going to put parentheses. I like to put parentheses because in case I'm plugging in a negative, then I won't mess up. Because the negatives are tricky sometimes to plug into. So this x squared, I'm going to plug in the 3 squared. Minus 6x, I'm going to plug in minus 6 times 3. Is it true that negative 6x is actually negative 6 times x? Yes, that's why here we put negative 6 times 3, plus 4. Then we use our friend PEMDAS. Please excuse my dear Aunt Sally. That Miss Aunt Sally, she must, I don't know. She must be very impolite, and we always have to excuse her. Please excuse my dear Aunt Sally. What do we do first with PEMDAS? Parentheses, okay. Is there anything in these parentheses to do? Hey, guys. Is there anything in these parentheses to do? No. So there's actually no parentheses to do. Exponents. First I'm going to square 9 minus 6 times 3 plus 4. After exponents, Tyler, comes what after exponents? No, parentheses came first. Please excuse my dear Aunt Sally. There you go. Is there only multiplication? Good. I'm glad you said the negative 6, because it's true. It's a negative. What would that be, Tyler? Negative 6 times 3? Negative 18. Plus the 4. Now remember, addition and subtraction go left to right. So we subtract first. 9 minus 18 is negative 9 plus 4, which is negative 5. That is your y value. So guess what? This together is your vertex. A point has two coordinates, right? An x coordinate and a y coordinate. So our vertex is 3, -5. So if I did that on the graph, 1, 2, 3, 4, 5, there's my vertex. Look at your A. Is A positive or negative? Felipe, do you have a question? No? You just put your hand up? Okay. Positive. So therefore, the parabola is going up. Up, up, and away. Okay? So we can use, and A is 1. Oh, I erased it. From our quiz, if A is 1, are we going to have any change on the arms of the parabola? No. So we can follow the ratio, up 1 over 1, up 4 over 2. So I'm going to go up 1, left, and right 1. From the vertex, I go up 4, left 2, right 2. That's a nice pattern that happens for all parabolas. It works on all parabolas. If A is a multiplier, then you have to multiply the numerator by that A, and then it still works. Okay? What's the name for the vertex if it's at the bottom of the graph? No, the other one. It's a minimum. Okay. That was probably example 1. I'm going to give you a story problem here. You don't have to write it all down. You do need to write down the important information, so when you look back at your notes, you know what in the world it was we did. Here you go. Example 2. Just write down the important information. If it's already printed in front of me, I underline important information. Since it's not printed on your notes, you write down important information. During halftime of a basketball game, a slingshot launches T-shirts at the crowd. A T-shirt is launched with an initial upward velocity of 72 feet per second. Kevin, what's something that would be important to write down so far? And I'd also write down what that means. What is 72 feet per second? So what type of velocity? And the word initial? Initial means starting velocity. Because is it going to stay at the same velocity forever? Nope. No, with gravity, that will slow it down, right?
And also eventually it hits someone.
Yeah, and then it stops because it hits someone, felt someone in the face or something. Okay, the T-shirt is caught how far above the court? 35 feet above the court. How long will it take the T-shirt to reach its maximum height? I would write down the question. How long will it take the T-shirt to reach its maximum height? We'll start with that first question and stop. In your book on page, I hope you brought your books, on page 130, there's a basic standard quadratic physics formula that will apply to all of our launching problems. And we've actually already seen some of this when we did our following object quizzes. You'll see familiar numbers. Could you turn to page 130 in your book, find the blue box, and stand up when you know the formula we would like to use on a launching object problem. Page 130 in the blue box, stand up when you know the formula that would probably be helpful to use in a problem like this where we're launching a T-shirt.
Can you say
130. Page 130 in the blue box, stand up. Oh, guys, where are your books? You're still writing? Sorry. 130 in the blue box, stand up when you know the formula for launching that would be helpful to solve our launching a T-shirt problem. Do a stretch break. For the pledge of math. Did I tell you the math commandment I heard on Monday? Yeah. Yeah, it said, Christians have 10 commandments, mathematicians have 1. Thou shalt not divide by 0. Because what happens when you divide by 0? Error, it's undefined. It's undefined. Okay, have a seat. So, Katie, you're up. Can you tell me the formula you found on page 130? And everyone else quiet, please. Katie, when they're quiet, you can tell me. What'd you get? Good. Thank you. Doesn't this look exactly like our following object equations that we had on our test, except for we have a VT in the middle? Yeah, it's exactly the same. Okay, and sometimes this V we call V naught. Actually, prefer it with V naught. Your book doesn't have V naught. Whenever you see a naught, that means initial. And it tells you in the paragraph what each of these letters represent. Well, T is obviously time. What is H? Height over time, right? At any given time. What is V naught? Initial velocity. Time. T is time. Okay, and C is the starting, what do you mean by point? Height. Or can we also say initial height? Okay, so if we want to find how long it will take to reach its maximum height, first of all, we have to decide which variable that is. Which variable will we be solving for if we want to know how long it will take to reach its maximum height? We'll be solving for T. Interesting. This has H's and T's. If we were to graph this, what would the graph of the t-shirt take as it's being launched? What does that look like? Oh, can it go this way? I saw some people going that way. No, that's backwards. Could it go this way? No, it actually doesn't start at 0. Look at the picture. And there's more information on the picture. It starts at 5 and then it gets caught actually up here, doesn't it? So our x-axis is actually our t-axis, that would be time. And our y-axis is actually the h-axis, which is height. So if we're solving for t, we're actually, if we want to find its maximum height, tell me when to stop when I hit the maximum of my poorly drawn graph. Yeah. What is that point called? Well, it goes through the x-symmetry, but what's this point called? The vertex. And we just, since this is in standard form, we just got the equation for axis of symmetry, which we can get the vertex by using the axis of symmetry. So, let's plug in. H equals, I don't know the height, negative 16. Actually, I do know the height. How long? Nope, I don't know the height, sorry. We need the full standard form yet. Do we know the initial velocity? 72 feet per second, and we just have to write the 72. T plus, do we know the initial height? It is not 35, that's a trick. It is 5, you have to look from the picture. So, axis of symmetry formula is x equals negative b over 2a. Negative b over 2a. So you have to look at our very real life problem, so not as pretty numbers as our first example. What is in the b position? Rika, what number is in the b position? It goes in alphabetical order, A, B, C. 72. And so we'll do opposite of that, so negative 72 over 2 times what is in the A position. Dylan Daniels? Careful. negative 16. So I get, let's see, negative divided by negative is a positive, correct? So I have 72 divided by 32. Can you divide that out for me? Real life isn't as pretty. Divide it out. 2.25. So x equals 2.25, and this is seconds. Because isn't the time, the x-axis seconds? Yeah? Yeah, because it says here feet per second. So there's our first answer. It will take 2.25 seconds to reach its maximum height. Now the question is, what is the maximum height? If you're finding the maximum height, which axis are we looking at? The y-axis, which is acting as our h-axis. So if I know that right here has an x value of 2.25, if I know the x value, how can I find the y value? Yes. In place of the t, good, because the horizontal axis is the t. So we replace all of the t's. This is what calculator would be really helpful, because real life, not so pretty numbers. Replace all of the t's with 2.25. If you need a calculator, they're waiting for you. Plus, you guys can always get those calculators at the beginning of class when you come in. Grab a calculator. Let's do that. Look at all these calculators waiting for you. I see an empty desk. Come get one. Stand up. Come get a calculator, please. They're waiting. Okay, type it in. You can actually, does everyone know where the squared button is on your calculator? It's diagonally up from the 7. It's the x squared button. Okay. 5 more seconds. A really long 5 seconds. Talia, what did you get? Talia, I'm so sorry. Talia. Adam, what'd you get? That's not what I got. Did I type it in wrong? I got 86. Did you make sure you use the square? If you type it in exactly like this says. Coming up. Yeah, you type in exactly negative 16, parentheses, 2.25, close the parentheses, you have to do that squared, plus 72 times 2.25, close the parentheses, plus 5. Oh, I did something wrong. Yep. Okay. Oops. Second entry. What's it doing? I don't want to answer. Yeah, it's going to make me retype it. It is the virus. 2.25, did you get the 5 this time? Squared plus 72 parenthesis 2.25, close the parenthesis, plus 5. That's okay this time. 86. What does that number mean? Adam, what does the 86 mean?
That's the maximum height, right?
Good. We solved for h. That is the maximum height. H equals 86. Do we have a unit for its maximum height? Because the story problem should always have a unit on your answer. Feet. Is it feet per second? It's just feet. Feet is the maximum height. Good, guys. And that's actually our vertex. If it asks what is the vertex, it is 2.25, comma, 86. Whoops. Okay, there's one last question in the problem. It says, what is the range of the function that models the height of the t-shirt over the time? Okay, you and your neighbor, you guys know how to do range. We've been practicing range. You got it. You and your neighbor discuss what the range and be specific on parentheses and brackets. What is the range? Whose is this?
That's mine.
Your battery's falling out. The range. Make sure you know brackets versus parentheses. And write it on your paper. I'm going to come check. You got the range?
Yeah.
Write it on your paper, please. That was really kind and polite how he asked you.
Whoa! Need there. Good, but you got it.
What's the range? Let me see, guys.
Is that not it?
Now, this problem, the graph doesn't go down forever because it's a real life problem. So you have to think, what's the lowest point that the t-shirt ever is at? Oh, so what's the highest point the t-shirt ever goes? Ah, yeah,
Dylan, why didn't you?
better.
Told you.
Okay, range time, R sub Y. Who wants to volunteer their neighbor? Who that?
Great job.
Are you going to get Adam? Okay.
So it's
Right, let's see how it does.
5 feet to 86 feet.
I need a little more specifics.
Feet.
I don't need the feet.
Yeah. Parentheses.
Okay, let's talk about why. Is there an actual point at the 5? Yes, so there's a point there. If we're actually going to meet that point, bracket. And are we actually going to meet 86? Bracket. And it goes up to 35, right? My picture's not drawn very well. Probably 35 would be more like down there. Okay, so in problem 2 that we just did, a t-shirt is launched with an initial velocity of 64 feet per second and is caught 35 feet above the court. How long will it take the t-shirt to reach its maximum height? How high will it go? And what is the range? You and your neighbor, same question, but what has changed?
The velocity.
Velocity has changed. Same question, but velocity has changed. So the picture still applies. 3 questions. How long will it take the t-shirt to rise at its maximum height? How far above the court will it be? And what is the range? You guys can do it. With your neighbor, work it out. Has something to do with gravity. Something like that. Yeah, it's a physics problem. I've actually never taken a physics class, so I think it would be fun. It's the same picture. So, same picture, but they're going to give it more pull before they launch, so it has more of a velocity, right? Because before the velocity, no, it has less velocity. Because it's now the velocity is only 64. Before they gave it 72 velocity. So, where does the t-shirt start initially in height? 5. Everything else is the same, it's only the velocity has changed. You done? Hey guys. How are you doing? Yeah? Let's see your progress. Well, would you start, please?
Trying to think like how to set it up.
Well, I would start by plugging into that formula. Remember the formula she gave us from the book? This guy?
Oh yeah.
You need to plug in your velocity, your initial velocity, and your initial height, and then you'll have the standard form. Just do the exact same steps we did last time. Find the x, how long it takes to reach maximum height, and then we plug that in to find how high it actually goes. Okay? So you need to identify your initial velocity and your initial height. How are you doing? Is this your new one? And it's right. Is this the formula you used? And you just put it in your calculator? Okay, yeah, because it's 64 this time. Okay. And you did negative b over 2a. Negative b, so 32 over 2a. And I still think this is 5. Yeah, because that's where the t-shirt starts. They launch it from a height of 5. So it's the initial height. How high does the t-shirt start? Does it start at 2 feet off the ground? Yeah, that's your range, right? Yeah. Let's see, guys. Good. Good job. Good job. Here we go. Okay, you guys have different answers.
What?
The initial height is the same, but your maximum height. Okay. Derek, you have a different answer than these guys. So would you compare work? Someone's probably, I haven't solved it yet, so probably one of them is right. What did you get? Okay. So can you answer all 3 questions? What is the time it takes to get to the max?
Oh,
How high does it reach, and what's the range? Okay, I see a common thing actually going on with the range, guys. Is the x value you got 2? That has nothing to do with the range. The t-shirt starts not at 2 feet. It starts at what feet above the ground? 5. And then it's launched to something higher. I believe so. Good job. Okay. You have 40 seconds. I think that is right. Good job. That's what everyone else is getting, so I'm going to go with a yes on that. You got that? This number is wrong because when you plug back in, this isn't 72 anymore. It's that. What did they change it to? 64. So retype that in and I bet you'll get the answer. Okay, I need everyone's attention up here, please, in 5, 4, 3, 2, wonderful, 1. Remember your formula. This is standard for any launching problem. So, we need to set up our standard form first. Shout it out. What was the initial velocity? Plus 64. And the initial height? 5. They never said that initial height changed. Okay, so to find how long let's see, first question, how long will it take the t-shirt to reach its maximum height? That is the x-axis or the t-axis using the axis of symmetry. X equals negative b over 2a. And it looks like we're doing really good on that. What's in the b position? So we write negative 64 over 2 times negative 16, which is negative 64 over negative 32, which is 2. So, what does the 2 mean? 2 seconds to the maximum height. 2 seconds to max height. Then you plug in the 2, and this is where some people are getting wrong. If you were getting, I can't remember, but the error was that you were still using the 72, and you were supposed to be using 64. So when you insert in the 2 for all the t's, you should have gotten 69. Is that right? 69 is the max height. Alright, please, I have one more thing to say before I tell you what your homework is. I'm waiting patiently. The range. Guys, I saw this on many, many papers. The 2 is not part of the range. The lowest point in the t-shirt is 5. And then it goes up to 69 bracket. Great job, guys. Good job working on that. Here is your assignment. 21 problems on those. Axis of symmetry, finding the vertex, a launching problem. If you have one of my calculators, please bring it back, yeah? We're gonna what? This is in the book. I have books in the back if you don't. It'll be on my website, MissGraceMath.weebly.com. And I'll send out a text today after school. Well, yeah. I'll probably schedule a text for tomorrow, so you remember over the weekend. Yeah. That's my last one. Okay.